I'm Anil Kumar. Welcome to my series on fractions. We are calling it Fractions for Kids only because we are using the blocks with which kids play. So, fractions is, in a way, as simple as playing with these blocks. We'll understand the whole story about fractions using these blocks in this particular video, and I hope you'll find it interesting and useful. This video is for my junior and middle school students. Now, when we say fractions, what comes to our mind is it is all about sharing, right? Fractions is all about sharing. It's kind of like this. You have a chocolate bar and you share half of it with your friend. So you gave a fraction of it, and this fraction is half, right? You could do this half in many ways. You could have some piece like this and you can give half of it, right? So you could give half of it, or something like this. You have one full piece like this and you decide to give half away. So it's a fraction, a part of whole, right? So that brings us to part of whole. So you give a part of whole to your friend, and so it becomes a fraction. You get my point, right? So we'll also talk about fractions as a ratio of numbers. So till now we talked about half, which is written as 1 over 2. So what really happens is that if you have, let us say here, something which could be cut into 6 pieces and all 6 same size, this is very important, all 6 same size. In that case, if you want to give half, you'll give out 3 of them, correct? So you give out 3 of them. That will leave you with half and your friend gets half of it. Do you see that? So these 3 slices which have been taken away represent half of the whole. So what you saw here is that fraction is all about sharing, and it is also part of whole, and it is also part of something, right? So that's all it is. Like this is one whole and we took away half of it, right? So that is the half of it taken away. So that is what fractions is. And as you have seen, we will write fractions in terms of numbers, writing as a ratio 1 out of 2. Now you get 2 if you divide your whole into 2 equal parts, let us say. So we have a whole, we divide it into 2 equal parts, so that number of parts is 2. And when you take away 1, that is what is given on the top. So that is how we will describe fractions as we move along. So I hope this concept is getting clear as we move on. And to give you technical terms, numerator and denominator. The number which we write on the top will be referred to as numerator. And the number which we write at the bottom is the denominator. So whenever you write fractions, you have to see in how many parts do you divide. So here, for example, you divide in 2 parts. So that 2 comes in the denominator and you give away half of it, means 1 out of it. So 1 given away. So 1 goes in the numerator. You get an idea, right? So let's take up another example to understand this concept, and then we'll move forward, right? So here we have another piece in which what I have done here is that I have divided this into 6 equal parts, correct? Now this is divided into 6 equal parts. So what goes in the denominator? Since I divide this into 6 equal parts, the number 6 goes in the denominator. You get the idea, right? Now, out of these 6, I give out 2 to my friend. So that goes in the numerator. 2 out of 6. You get the idea, right? So that is how you represent what is missing here. Well, 4 remains, but 2 are missing because we gave it. So we could say a fraction is 2 over 6 or 2 out of 6. So now we could write this as 2 out of 6, or we could also read this as 2 over 6. So basically we divided the whole. So what we did here, we divide whole in 6 equal parts. So that is this 6. That comes in the denominator, and from that what you do is you take 2. Take or give away. Give 2. So that part which you give comes in the numerator. You get an idea, right? So what you give away is in the numerator, right? So you take or give 2 comes in the numerator. So that is how you represent a fraction. So I hope that is absolutely clear. So you can play with such blocks, and then you will know that we could do different parts. So we'll now explore, can we divide in only half, or we could divide in many more parts? Well, here is a piece for you, right? So this has been divided into 3 equal parts. So what will come in the denominator? 3. And if you give out 1 to your friend, then the numerator will have 1 on it. So that small triangle represents 1 out of 3. Do you see that? So the whole was divided into 3 equal parts, and one of them is given to your friend. So that is what the fraction is all about. So I hope you have got good concept. Now let's take more examples and questions based on part of whole, part of something, ratio of numbers, numerator, denominator, and then we'll also answer a very significant question. Are the two halves equal? Third, how about 1/4 greater than half? Is that possible? And then I definitely will thank you for your time, and we can actually see time also as a fraction. Next topic will be fractions be bigger than 1. So that is the next video. But in this video, we'll further explore part of whole, right? So let's go and understand what is part of whole in all, right? So we'll do more examples. I hope you have learned about sharing now and you totally understand. Let's play a game. I have got these, how many pieces? I have 8 of these chocolate pieces, and I decide to give away 5 to my friends, right? And keep 3. So out of 8, if I give away 5, then what fraction do I give away? That is what you have to figure out. So we'll write down the numbers which represents fraction shared. So tell me, what fraction did I share? Out of 8, I give away 5. So to write in terms of fraction, I will say out of 8, I give away 5. Does it make sense? Correct? So that is what sharing is, and that is how we could say. Now, if I give away 4, let's say, and keep 4, this I'm giving away out of 8, in that case, I will say I gave away 4 out of 8. Now, you will also notice that this 4 is actually half of what I had, right? So, 4 out of 8 is as good as half of what I had, right? So, think like this. I could actually divide my bar into these 2 pieces. You get the idea. And if I break it from the center, I give half of my bar to my friend. So I share half of it. But as you can see, 4 out of 8 and 1 out of 2 is kind of same, right? So it's the same fraction. So fractions could be written in different ways, right? We could say 1 out of 2, right? Or we could also say 4 pieces out of 8 pieces. It all depends how we break it into. So if I break it into 2 parts and give away 1, it is half. But if I do 8 pieces, kind of like this, and then give away 4, we'll say 4 out of 8. However, the quantity received by the friend is the same thing. You get my idea, right? So that is how we can look into fractions. And actually, I could make 3 out of 5 also. I could give 3 out of 8 and keep 5. So I could have another combination that from the 8 pieces, I give away 3. So that will be 3 out of 8. So that is sharing. Do you see how we could say sharing with the help of fractions? Now let's take another example and let this be kind of test for you. This time I'm dividing my cake into 6 equal parts. Now, if I decide to give, let us say, 2 pieces to my friend, then what fraction of cake did I share? Well, I divided it into 6 equal parts, so 6 comes in the denominator, and what I gave was just 2. So it is 2 out of 6. You get an idea, correct? 2 out of 6. And let us say, if to the other friend I gave 3 of my remaining pieces, then each is 1/6, right? Each piece, because we had 6 equal parts. So this is 1, 2, 3. So these 3 pieces represents 3 out of 6. What remains is 1 out of 6. Do you see that? What remains is 1 out of 6. Now if I add all the 3, what do I get? If I add all the 3, I get 2 plus 3, 5 plus 1, 6, and each is 1/6. Do you see that? 6 out of 6, which is 1 whole. So if I add them all together back, I get 1 whole. So that is how fractions are kind of related. So I hope that gives you another understanding of fraction. Correct? So if I divide the whole into 6 equal parts and give some to my friends, and if I collect them back, I make the whole. Correct? Do you see that? So that is another way of looking into fraction as sharing and collecting. Do you get an idea? Right? So that is very important concept. Now let's move on and see the next concept, which is part of something. So let's look back at part of whole. So here I have one hexagon. So what I've done here is that I have divided one hexagon into 6 triangles. So what I have is one hexagon and I divide it into 6 parts, which are represented by these 6 triangles, right? So that is what I've done, as you can see here. Now my question is, how much is this one triangle equal to? So if I have to say, what is this one triangle equal to, how will I write this triangle in fraction? Well, it could be written as 1 out of 6, since I divided the whole into 6 equal parts, right? Or I could also say as 1/6. Do you see that? So there are different ways of writing fraction. You can say it as 1 over 6 also, right? So let me write here another term, which is 1 over 6. All represent the fraction 1/6. Do you see that? So this green triangle represents 1/6. So if I have now, let us say 2 of these we got three of them. Okay, so if I have three of these triangles, they represent how much? In fractions, these three triangles will represent 3 out of 6. Do you see that part? So we could say that each piece is 1/6. If I take more pieces away, I get more fractions. So 1, 2, 3, 4, 5. Now this represents 5/6. Do you see that? 5/6. So if the denominator is same, we can compare fractions. Correct? So you can now understand how to compare fractions. So you can say that if I have to write these fractions in increasing order, if I have to write them in increasing order, how do I write? I should write 1/6 first, correct? That is smallest, so 1/6. And then bigger than that is 3 out of 6. And even bigger is 5 out of 6. So if we have same denominator, then we can compare fractions with numerator. So same denominator. Do you see that? So when we say part of a whole, and if we divide the whole into some equal parts, in this case it was 6, then who gets more can be decided by the number in the numerator. Do you see that? So that is how we could also look into fractions. We can compare fractions provided we have the same denominator. This is important to consider, right? So I hope you understand that a whole could be divided into different parts. So let's take another example. Here we are dividing only in two parts, right? So if I take away half, what remains is half. So the important thing is that we are dividing it into two parts. So 2 goes into denominator, and what is given out is in the numerator. Now here is a test question for you. I have a block which I divided into into 3 equal parts. So what I've done here in this particular case is that we have a trapezoid, right? So we have a trapezoid, and what we did, we divided into 3 triangles. So each triangle now is how much? In this case, each triangle is 1/3, 1 out of 3, correct? So whole is equals to 3 out of 3, right? And what you notice is that the whole is equals to 3 out of 3. So all these 3 parts together make a whole. Right? So we could actually get back to the whole by adding the fractions. Correct? So let's move on and take some more examples. Now, here is a question for you. Part of something is missing, right? We have a hexagon which is divided into 2 equal parts. One is missing. We have a trapezoid which could be divided into 3 triangles, but 2 of them are missing. Here we have hexagon which could be divided into 6 equal parts. We have only 2 left. Now the question is, you have to write in fractions what part is missing. Take your time and write down the answer. What part is missing in all the 3 cases, right? So let's begin. I hope you got your answers by now. So in the first case, we divided into 2 equal parts. 1 part is missing. So 1 out of 2 is missing. Now here, we could have divided into 3 equal parts, and what is missing is 2, right? So in this case, it is 2 are missing, and we could have divided it into 3 equal parts. Correct? How about this? You could have divided this into how many parts? 6 equal parts. You have only 2 out of 6. How many are missing? 6 minus 2, which is 4. You get an idea, right? So that is how you could at times find the missing part, right? So if I add this 1 to what is there, I get 2, the one which you have in denominator. If I add 2 to 1, I get 3. If I add 4 and 2, I get 6. So that gives you an idea. The missing part and what we have always will be total to, or the sum of that will be the denominator. Equal number of parts, the whole was divided into. Correct? So that could be another way of looking into fractions. Now let's take a few more examples. Now let us again look into numerator and denominator. When we write fractions, we write a number on the top which is called numerator, correct? And number at the bottom is called denominator. Now in this case, we have a hexagon. If I divide hexagon into 6 equal parts, then what comes in the denominator is the number 6, right? So the number of parts we divide into, which is 6, comes in the denominator, right? So like this, right? 6 parts. Now how many do I have? I have only 4 out of 6, correct? I have only 4 out of 6. So the number 4 goes on the top. So what I have. So 4 out of 6 is what I have. So sometimes the question could be what is missing, and sometimes it could be what I have. Now, can you write down in fractions what do I have in this part? We have 1 trapezoid and 2 triangles. While in this particular case, as you got it, we could have divided it into 3 parts, 1, 2 and 3. So in this case, we divided it into 3 parts. I have 2 out of them, so 2 goes in the numerator. So what I have is 2 out of 3 in this particular case, correct? Now I could also ask you a question, is what is missing? So now take your time to figure out what is missing. So what I have, so we have these 2 things, 4 out of 6 in this case and 2 out of 3 for the trapezoid. Now we have to write what is missing. So for missing, we know we are missing 2 out of 6. So 2 out of 6 is missing in first case, and here 1 out of 3 is missing. 1 out of 3 is missing. Do you see that part? So we could write fractions for what we have and what is missing. But when you add both, you get 6 out of 6 in the first case, which is 1 whole. 2 out of 3 plus 1 out of 3 is 3 out of 3, 1 whole. So adding what we have and what is missing will give you the whole. So that is how we can again look into fractions. So I hope you are now very clear what to write in the numerator, what to write in the denominator to represent missing or what we have as fractions. Clear? So let's move on and take up some more examples. Now here is another question for you, which is, are the 2 halves equal? What do you think? Well, the answer is not always. For example, see this. This is a half, right? And how about this? It also represents half, right? Now we know this is bigger than the other, correct? They are not equal. Both are halves, 1 out of 2. This is also 1 out of 2. So what makes them different? How big the whole is. That is the answer, right? So the answer here is it depends on how big the whole is. Correct? If the whole is same size, then they are same. If the whole is bigger, then the half is bigger. If the whole is smaller, then the half is smaller. So the two halves may not be always equal. So that's very important to understand. I hope you got it. Now we have another very interesting question for you. How about 1 out of 4 greater than half? Is it possible? Tell me. Can 1/4 be greater than half? What do you think about it? Let's look into it. Let's say we have these 4 pieces and I take 1 out of them. And I have on the other hand these 2 pieces, and 1 out of 2 means 1 out of 2. Which is greater? Clearly 1/4 is greater, right? So this, because what we saw here is that 1/4 is greater. Why is it so? Simply because the whole was much bigger. These were much bigger pieces than those. Therefore, 1/4 was greater than half. So at times you could have 1/4 greater than half, as you can see in this particular example. Fractions is only part of the whole. So if whole is bigger, the parts will be bigger. So if there is a bigger pizza, every slice will be much bigger than the slice from a smaller pizza. So you got this idea. Perfect. Now let's move on and take another very interesting question. So let me thank you for your time. Now you see time in different types of clocks. Let me make different types of clocks here to show you different types of times. Now these are my clocks, and let me show you a time here. Let's say this is at 12 and the other needle, which is the minutes needle, is at 3. Then it represents how much of the whole circle, how much of an hour. In this case, I have the needle somewhere here, the other one on the other side. What fraction has the minutes needle moved? And in this case, let's make it kind of like this. Now, what you need to figure out is, in each case, how much of an hour the needle moved, right? So in this case, it moved from here to there. So that is quarter, 1 out of 4. Do you see this? In this case, it moved half. So it is 1 out of 2. And here, you could think about 4 quarters and moved 1, 2, 3 quarters. It is 3 out of 4. So in time also, we could see fractions. Half an hour, for example, represents half of an hour. 3/4 of an hour is also fractions, and quarter of an hour is also fraction. So time, when we look at, is a good example of fractions. You can see it right there. So thank you once again for your time, and I hope you enjoyed this journey of learning about fractions. In part 2, we will see equivalent fractions and then learn how to add and subtract fractions. I hope you'll find it very interesting. Feel free to write your comments and share your views, and if you really like my videos and subscribe to them, that'd be great. Thanks for watching once again.